Have you ever looked at a website like Wikipedia and wondered, how on earth do you build something like that from scratch? Well, today, that's exactly what we're going to do. We're going to start with a totally blank slate and build our very own working mini Wikipedia. Let's jump right in. So here's the goal. A simple but real wiki application. We want to be able to create pages, view them, edit them, the whole shebang, all served up live on the web. Now, I know that sounds like a huge project, right? But stick with me and you'll see exactly how all the pieces fit together one step at a time.
All right, first things first. Before we even think about websites or servers, we need to answer a really basic question. What is a wiki page? We have to define its blueprint in our code.
To make that blueprint, we use something called a struct. Honestly, the best way to think about it is like a recipe's ingredient list. It's just a simple container that holds all the related bits of information together in one nice, neat package. So, for our wiki page, what are the essential ingredients?
Well, here's that blueprint in actual code. A page is really just two things: a title, which is just some text, and a body. Now for the body, we're using what's called a byte slice. Don't let the name scare you. Just think of it as the raw fundamental stuff that makes up any file. It's perfect for saving our content.
A blueprint is cool, but it's got to do something, right? So the very first thing we need is a way to save our pages. We attach a function, it's called a method in this case, directly to our page blueprint. This save method is super simple. It just takes the page's title, slaps .txt on the end, and writes the body into that file. Done.
And of course, if you can save a page, you've got to be able to load it back up. So this partner function, loadPage, does the exact opposite. You give it a title, it finds the right text file, and reads the content back into our page structure. And here's the crucial part, it's also designed to return an error, just in case that file doesn't actually exist.
Okay, so right now our wiki is kind of lonely. It only lives on our own computer. To share it with the world, we need to get it on the web. And that means we need a whole new set of tools.
The absolute key to this is the web handler. You can think of a handler as a traffic cop for your website. A request comes in from someone's browser asking for a certain URL, and the handler's job is to see that request, figure out what to do, and send the right response back.
So, this is our very first handler. It grabs the page title from the URL, loads the page data, and then, well, it just crams a whole bunch of HTML right there into the code to display everything. Oh, and you see that little underscore? That's us telling the code, yeah, I know load page might give me an error, but yeah, just ignore it. It technically works, but it's messy, and it's super fragile.
And that mess brings us to our first really big upgrade. Mashing your programming logic together with your presentation, all that HTML, it's just a recipe for disaster. We have to pull them apart.
And the source material says it perfectly. This is not a new problem in programming, and there is a much more elegant solution: templates. This lets us keep the structure of our web page totally separate from the code that powers it.
And just look at the difference here. It's night and day, right? On the left, you've got that ugly, impossible-to-read blob of code and HTML all tangled up. And on the right, a clean, simple edit.html file that a designer could actually work with. The Go code's only job now is to fetch the data and hand it off to the template. So much better.
And you know what the best part is? We can create one single reusable function, this render template, to do all the heavy lifting. Now, both our view handler and our new edit handler can use the exact same function. We write the logic one time and we reuse it everywhere. That is a massive win for keeping our code clean.
Okay, so our app works, and the code isn't a total disaster anymore. That's progress, but it's still fragile. You know, if anything unexpected happens, the whole thing just breaks. So now, we've got to make it robust. We need to handle errors gracefully and add some security.
Let's start with a really common situation. What happens when a user tries to go to a page that doesn't exist yet? Right now, because we're still ignoring that error from load page, they just see a blank white screen. That's a terrible experience.
The solution here is just so clever. We turn the error into a feature. Instead of showing a broken page, we check for the error. If we see that the page doesn't exist, we just redirect the user to the edit page for that same title. The problem is solved, and now the user can create the very content they were looking for.
Now we gotta talk about something much more serious. The source points out a massive security hole. As it stands, a clever malicious user could trick our app into letting them read or even overwrite really important files on our server. We have to plug this hole, like right now.
The fix is something called a regular expression. Think of this line of code as hiring a bouncer for our URLs. It creates a strict pattern. It says the URL must start with /view, /edit, or /save, and it must be followed only by standard letters and numbers. Anything else tries to get in, the bouncer throws it out immediately.
Okay, deep breath. We've made our application functional, clean, and now it's secure. The final step is to make it elegant. This process is called refactoring, where we polish up the code and make it more efficient without actually changing what it does.
Remember that awesome URL bouncer we just hired? Well, right now, we're having to put a copy of that validation check in every single one of our handlers: view, edit, and save. And that repetition, that's a classic code smell. It's a sign that there's a better way.
And here's that better way. It's called the wrapper pattern. It's so cool. Instead of putting the validation logic inside each handler, we create a new function that wraps around our handlers. This makeHandler function has the validation logic in one single place. It checks the request first, and only if it's valid does it pass control along to the handler that was supposed to get it.
And just look at the result. Look how clean and simple our view handler is now. All of that validation boilerplate code, it's just gone. The handler is now totally focused on its one core job: loading a page and showing a template. This is what professional, maintainable code really looks like.
So let's just recap this whole journey. What did we learn? We saw how to start with a dead simple core, our page struct. Then we separated our looks from our logic using templates. We turned annoying errors into helpful features. We learned to validate everything the user gives us. And finally, we refactored our code with wrappers to keep it beautifully clean and efficient.
And that really leaves us with a final thought. This whole cycle we just went through, building something simple, finding its flaws, and then refining it to be stronger and more elegant, that isn't just some textbook exercise. It's the fundamental process. It's how pretty much all great software is actually made.